So we kind of made the discoveries of the rules for monomials, okay? The big thing is where there's a difference between multiplying monomials and monomials to a power, okay? Now we're going to look at it with actual problems that we will be doing in class. So multiplying two powers with the same base, when we do that, we add the exponents, okay? So for example, if I have a to the m power times a to the n power, it's a to the m plus n. We're keeping the base the same, we're adding those exponents. So for example, here, a to the 4th times a to the 12th, that's really a to the 4th plus 12, which equals a to the 16th. So let's try these three examples here. X to the 7th times x to the 20th, 7 plus 20 is x to the 27th. Y to the 5th times y to the 123rd, well 5 plus 123 is 128. M times m to the 15th times m to the 21st. I'm first going to tell you the most commonly incorrect answer that I get is m to the 36th. That is incorrect. Because they'll be like, oh, this is 0 plus 15 is 15, plus 21 is 36. The problem is that m isn't to the 0 power, even though it's not there, it's really to the first power. So it's not going to be m to the 36th, it's going to be m to the 37th. Do not make that mistake, that's a very common error. So that's just basic monomials, okay? Now we want to combine some numbers and some variables. The important thing when we have monomials that have numbers and variables in it is realizing that just because we have special rules for the variables doesn't mean that we change how we multiply numbers. We're not going to all of a sudden say that -5 times -8 is -13 because we're adding. We still multiply the numbers. It's just that when you multiply the variables, we add those exponents, okay? So step one is we're going to multiply the coefficients together. Then we're going to multiply the like variables together using our rule, okay? So if we look at this, we've got -5 times -8. So we're first multiplying those two. Negative times a negative is a positive. 5 times 8 is 40. Then we're going to do our a's together. So a to the 9th times a to the 6th, when we multiply variables with exponents, we add. 9 plus 6 is 15. Then we've got b's in both of these. So b to the 3rd times b to the 4th, we add. 3 plus 4 is 7. There's only a c in the second one, so we're still just going to include that in the end. We don't have to add that with anything else. Number 5. Okay, we're going to multiply the numbers. We don't add them. -4 times 5 is -20. We've got the x's we need to combine. Remember, if there's just one x there, that is x to the first power. We have 7 x's, we have 1 x, we add those together, we get 8. Same thing with the y's, that's y to the first power. So you have y to the 11th plus 1 is y to the 12th. One thing to remember when doing this, the proper way to write this is with constants always, and constants really, coefficients always go first, right? They're the coefficients there. And variables are generally written in alphabetical order. Okay, if you want to make sure that your answers are correct, you should be going in alphabetical order. That's the proper way to write it. So what I would like you to do is to try these U-tries on your own, 6, 7, and 8. We'll come back and check those in the end. Now we're looking at powers of monomials. So to find the power of a power, remember that we multiply the exponents. So for example, if we have a to the m power to the nth power, that equals a to the m times n instead of plus n. So here we have a to the 4th to the 8th power. That means a to the 4th times 8th, which equals a to the 32nd. So if we try these, the biggest thing to note is that exponent on the outside applies to everything on the inside. So the 5 applies to the x and the y. So x to the 7th to the 5th power. 7 times 5 is 35. So x to the 35th. Now for our y to the 2nd to the 5th, you're doing 5 times 2, which is to the 10th power. So x to the 35th, y to the 10th. For number 10, this 3rd power is applying to all 3 terms on the inside. So a to the 7th to the 3rd, 7 times 3 is 21. B to the 6th to the 3rd, 6 times 3 is 18. And C, the coefficient, or the exponent isn't there, that's power of 1. 1 times 3 is 3. So that's when it's just variables. The last thing we're going to look at is when you're multiplying monomials with numbers and variables, okay? So again, evaluate the numerical part using the standard exponent rules, not multiplication, right? So if you have 2 to the 3rd power, that's not 2 times 3, that's 2 times 2 times 2, which is 6, okay? Then evaluate the variables by multiplying the exponents. So for number 11, okay, we've got 2. It has to be applied to both terms on the inside. So 8 to the 2nd power is not 8 times 2, it's 8 times 8, which is 64. B to the 9th to the 2nd power, 9 times 2 is 18. Number 12, this 5 on the outside is applying to all 3 parts, the number, the x, and the n. So negative 2 to the 5th power is negative 2 times negative 2, which is positive 4, times negative 2 is negative 8, times negative 2 is 16, times negative 2 is negative 32. Then x to the 7th times 5, 7 times 5 is 35. For n to the 6th to the 5th, 6 times 5 is 30. All right, these last 2 are where it gets really tricky. You got to pay close attention because not only do we have monomials to a power, but then we're multiplying those monomials by each other, okay? So you're looking at this in 2 parts. We've got this first part where you've got negative 6, r to the 5th, s to the 9th, raised to the 2nd power. And then we have this second part where we have 2, rs to the 3rd power. So first I'm going to break these down. I've got kind of part 1 and part 2. So negative 6, we're applying this 2 to all parts. Negative 6 to the 2nd power. Negative 6 times negative 6 is positive 36. R to the 5th to the 2nd power. 5 times 2 is 10. So r to the 10th power. For s, 9 times 2 is 18. So s to the 18th. Now we're looking at the second part here. This 3 is applying to all 3 parts on the inside. 2 to the 3rd power, 2 times 2 times 2 is 8. It's not 2 times 3. R to the 3rd power, r to the 1st to the 3rd power, 1 times 3 is 3. And s to the 3rd, 3 times 3 is 9. Okay? We've done the exponents. Now we are multiplying 2. Remember that when we multiply monomials, we add the exponent. So we're applying all parts here. Okay? So this is where I'm looking at each part that needs to be combined. I've got my numbers that I need to multiply. I've got the r values that need to be multiplied, and I got the s values that need to be multiplied. When we're looking at the numbers, remember that those are different. We're not doing 36 plus 8. We are doing 36 times 8. Okay? 36 times 8 is 288. Okay? Now with our variables, r to the 2nd times r to the third. We are multiplying, so we add. 10 plus 3 is 13. And then for s, we have s to the 18th times s to the 9th. We add those. 18 plus 9 is 27. All right, let's try one more there. We've got 5a to the fourth b to the second power. That's the first part that we need to look at. And then the second part, negative 2ab to the fifth to the fourth power. It's the second part we need to look at. Okay, so we need to take this 2 on the outside, apply it to all terms on the inside. 5 to the second power is not 5 times 2, it's 5 times 5, which is 25. A to the fourth power to the second power, 4 times 2 is 8. B to the second power is b squared. So that's our first part. Now we're looking at our second part. We're taking the 4 on the outside, applying it to all parts on the inside. Negative 2 to the fourth power. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. A to the fourth power is a to the fourth. B to the fifth to the fourth. 5 times 4 is 20. Okay? Now we need to combine each part. We're multiplying, so we multiply numbers like we normally would, and we add the exponents for the variables. 25 times 16 is 400. A to the 8th times a to the 4th, we add. 8 plus 4 is 12. B to the 2nd times b to the 20th, 2 plus 20 is 22. Go ahead and do those U-tries if you haven't done so already from the previous page.